Hi everyone, my name is Qin. I'm a software engineer from Databricks. So today I'm here to talk about the new Pulsar-spark connector that we introduced into Databricks Runtime recently. I feel really excited to announce that streaming Pulsar data source is available in Databricks Runtime since DBR 14.1. And then you can check the detail about the documentation in our website. So first, I'm going to walk you through the user journey of the new Pulsar data source. And then I will cover some of the technical detail and some of the challenge that we encounter when we are developing this source. So just like any other Spark data source, the Pulsar connector also supports all the major language. It includes Scala, Java, Python, and inside Databricks, you can also use SQL to declare your pipeline and build your pipeline. So the usage is really quite simple. You just create a streaming data frame in Spark by specifying the format as Pulsar, and then the only two required option is the service URL and the topics. And the syntax is quite simple in Scala and Python, which make it even more simple to use. And then in SQL, we use the SQL table function called readPulsar to create the streaming table that read from Pulsar. And then we can apply all the necessary transformation and aggregation on top of the streaming table and the streaming data frame. So if you are familiar with streaming, or if you are even familiar with Spark structured streaming, you know that streaming computation has different trigger mode, and they are used to enable different use cases. So some of our customers use the continuous streaming. When they use the processing type trigger, they can set the trigger interval to be very small or 0. And in that case, they can build real-time streaming application that is very low latency. And they can apply the rate limit with the admission control provided by the Pulsar data source. And underlying the processing type trigger, it is actually a long-running query that processes the new data as the new data arises. So it can be really low latency, and it is also very scalable and fault tolerant. But some other customers had different use cases. One of the major use cases inside Databricks is doing data injection and ETL. So in that case, people are more likely to use the available now trigger. So how does it work? The available now trigger is different from processing type trigger. It will process all the data at once, and then it will terminate the query. So people usually start an available now trigger query periodically, for example, weekly. And then because it batches the data processing, it can achieve very high throughput, and it is also very resource efficient. Because when you are not running the query, you do not need to allocate the compute resource at all. It's purely on demand. And especially with the auto-scaling, enhanced auto-scaling algorithm inside Databricks, it will allow you to save a lot of compute cost. And yes, so the different trigger mode for the Pulsar data source will allow you to build different applications in different use cases. Then I'm going to do a light demo and walk you through the journey of using Pulsar source inside Databricks. So as I said, the only option that is required for the Pulsar data source is the topic name and the service endpoint. with the Spark session, we call readString, and then we specify the data source as Pulsar. And then we also specify the required options such as service URL and the topic name. And then we call load. Then it's done. We create the Pulsar data frame. So let me run it interactively. So as you can see, we create a new data frame, and internally Spark will resolve the schema for us. It contains the key, the topic, the message ID, and the publish time, and all the message properties as a map. And you can see that the key and value are in the binary format, which is the default format in Fly Pulsar message. And then with this data frame, you can do whatever you like. But for simplicity, I will just do a very simple aggregation here. So first, we are going to cast the binary value into a human readable string. And then I'm going to group by the value field and do a very simple count aggregation. And then I'm going to display this aggregation data frame. So technically, it is impossible to display a streaming data frame in open source Spark because it's dynamic. The content keeps changing. But inside Databricks, we implement this function by starting a streaming query in the background, and it will maintain a table view in memory, and then the display will display the latest content in the in-memory table view. So let's try to run the query. As you can see, we start to initialize the string and launch the Spark job. But in order for the data to show up, we also need to start a data generator that keeps generating data into the Pulsar service. So this is a very simple data generator that runs in an infinite loop. And in each iteration, it is going to generate a message that contains a number from 0 to 10. And then it's going to send a message to the producer. And then we will see very soon the result will start to show up in this notebook cell. Yeah, as you can see, we are seeing the count or the value in this display table. And even better, we get the line matrix of the running streaming query. So you will be able to see the input rate and processing rate interactively, and you will see how much time it takes to do the computation. And you can see that because we are generating number from 0 to 10, there's only 10 keys in the group by. And then if you want to play around with it, we can even generate graph interactively and then adjust the graph and then download it. Well, I wouldn't do that to save time. Yeah, so you can see the query is running and the count keeps updating. And the matrix also keeps updating. Yes, that's the live demo that I'm going to show you. You can see how powerful and how simple it is to use the Pulsar data source inside Databricks. Now I'm going to cancel all the running data generator and the query. And then I'm going to talk about the authentication story for the Pulsar source inside Databricks. So as we all know, authentication is very painful in a distributed environment. Our Pulsar connector is based on the open source Pulsar connector, but it has many enhanced functionality. Authentication is one of them. So if you are using the open source Pulsar connector with open source Spark, basically because the configuration option, the credential file path only take the local file path. So you would need to install the credential file in every Spark instance, including master and the worker. And you need to, and this is very painful, and it is also not very secure if you are running in an environment, for example, that is multi-tenant. So we will recommend you to manage your secret in a Databricks style and do your authentication in a Databricks style, which is more simple, yet more secure and more powerful. So in Pulsar, when you are using the TLS trust store, you will need to specify the trust store password. If you are using the open source connector, you will need to hard code it into your code. This is not very safe, and then this is also not a good practice. So inside Databricks, you can use Databricks utility to manage your secrets. You can put the password and store it into a scope with a keep, and then you can get the password as a string. It will never show up as a plain text. Instead, you can use the string that you get from Databricks util and provide it into your streaming query. And then the story for the credential file is a little bit different, because we see a lot of users are using trust store and key store for mutual TLS authentication. So we add special support for it. You are allowed to store your credential file in UC volume, external location, or legacy DBFS. So they are all in the remote storage, and they all have very convenient file system interface in different language. And then you can upload your credential file very easily to this location. And then what's best is that you can use this remote location as your TLS trust store and TLS key store path in your query. So the supported format is various, and then it is very flexible. And because we are supporting the access to credential file in Unity catalog and external location, the access to this credential file will be protected by the fine-grained access control provided by the Databricks Unity catalog. So it is a role-based access control. Basically, if you upload a credential file, you will be able to grant the necessary access, and then when they are running the Spark query, even in a multi-tenant shared Spark cluster, the permission check will be enforced in every Spark task. So it's very secure. Only the owner of the file or only the people with the right access right will be able to access this credential and use it conveniently to build their own streaming query. And since we have go through the user journey for the Pulsar connector inside Databricks, I'm going to talk about some of the technical challenges we encountered. So one of the major feature asked from our customer is admission control. It is used for doing rate limit for the Pulsar data source. So the requirement for this feature is that user will need to be able to specify the maximum amount of data that is processed in a trigger, so that they can throttle the resource usage, and then they can control the SLA. And then we also wanted to achieve fairness across the topics and partitions that are inside the same streaming query. And we also want it to be backward compatible with the existing checkpoint by the open source connector. So one of the fundamental challenge, one of the questions that we need to answer is that how to calculate the number of message or number of bytes between two message IDs without actually reading the message. This is important because given two message ID, there's no convenient way to directly get the number of bytes or the number of message between the two ID. And if you are familiar with Pulsar, you will know that a message ID consists of the ledger ID, the entry ID, and the message ID is a 3-level index. And there's no convenient way to compute the number of the amount of data between two ID. So how do we solve this challenge? We use the broker statistic to estimate the size of data in each entry. And then because in each trigger, we know how much data we are going to process. And then if we are able to estimate the size of each entry, we will be able to calculate the number of entries that we are going to process. And in this way, we will be able to, given a star message ID, we will be able to compute the end message ID by adding the number of entries that we are going to process. And then we are going to process the data between the star message ID and end message ID inside a trigger. I would also like to talk about the testing framework that we built both in open source and inside Databricks, and the lesson we learned from the development and debugging. So we built a testing framework in Databricks and also the open source repo. For the open source Pulsar connector, testing is easier because it is just testing the vanilla open source Spark against a standalone Pulsar cluster. So it is based on the Pulsar test container and the Spark string test framework, which allow us to verify different aspects such as irrelevance guarantee and such as the matrix calculation correctness and such as the correctness of the admission control. But inside Databricks, the story is a little bit different. The testing will be more complicated because we are testing against many database-specific functionalities, such as the authentication with UC volume and also the SQL function that is only supported inside Databricks. So it can sometimes get tricky and sometimes involve many tricky words around manipulating the test container. Sometimes we need to expose extra ports and override broker configuration or copy file in and out for authentication use case. And when I'm debugging those tests, I find that it is quite powerful to use the log4j in both Spark and Pulsar as long as we redirect the log out of the container and into the console. We can troubleshoot the problem easily. And then because both inside Databricks and in open source, these tests are running in container. So we will be able to log into the container with Docker and then do interactive debugging, like checking the status of running process, as well as checking matches for disk memory and networks. We can go really low level. And what we learned from the testing effort is that we should try to decouple the subsystem. So even though the Pulsar itself is a very complicated component, but we try to keep it simple inside our test. It is only exposed as a service with the network address, including the IP and the port, and nothing else. And containerization allows us to decouple the two systems, Pulsar and Spark, and we will be able to debug them interactively and debug them in an isolated way. And because this containerized subsystem interact with well-defined interface through network core, it is also facilitate the development, because even though the internal implementation may be quite different in open source and database internally, but we have managed to make most of the interface keep the same, and only swap the implementation, underlying implementation. And then we also find that using Docker cell to debug interactively is very powerful and flexible, because we are going to get into really low-level detail of the system. And I would say that our Pulsar-spark connector is very open source friendly, because inside Databricks, the Pulsar streaming source is based on the open source Pulsar connector. And then it will be compatible with the open source Pulsar connector. So how do we think about this compatibility? First is the checkpoint format. Inside Databricks, the checkpoint format is fully compatible with the open source Pulsar-spark connector and open source Spark. So we are not trying to lock you in our platform with some proprietary storage format. So if you are already using the open source Pulsar-spark connector and open source Spark, you can keep your existing checkpoint and migrate to Databricks. And you can do it in a different direction. You can keep your checkpoint in Databricks and then migrate back to open source Spark and open source connector. And you won't experience any data loss because of that. And it also saves you a lot of compute resources, because you don't start the computation from scratch because of this guarding the old checkpoint. You keep the checkpoint, you keep the data, you save the cost. And then all the options supported by open source Pulsar connector is also supported by the Databricks Pulsar source. So in this way, when you are trying to migrate from the open source Pulsar connector to Databricks, it will require no change. It will also work in another direction, because even though we have actual functionality inside Databricks, maybe actual option, or maybe you are using the authentication in UC Warren, or you are using Unity Catalog with external location, but it won't prevent migration back to open source as long as you do very minimum code change. And if you are using all the open source options, then it's even zero code change. And yeah, you can see that there will not be any data loss, and there will not be much manual efforts if you're trying to migrate between open source and Databricks, and you can keep both of them and enjoy the benefits of both of them. I'm going to acknowledge the contribution of some of the engineers that have contributed to this project. So Eric in our team is working on the automation control and SQL interface support. And he has been very hardworking to make this project meet the deadline. And we are going to also thank Nan and other Stream Native engineers for their contribution to build the open source Pulsar-spark connector. And they have been very helpful. We have very tight deadline, and we contribute a lot of feature into the open source Spark Pulsar connector. And they have been reviewing code very timely and have been helping us with various issues. And then I will also thank Jelly and Praveen for their support to the project. Yeah, I think that's it. We walked through the user journey of the Pulsar connector inside Databricks,
and talk about our open source work and the technical challenge and do some deep dive. I'm happy to answer any question about this connector, about Databricks. Yeah, so now is the question and answer session.